Alright guys, in this video I'm going to take you through the last half of this review packet for your final exam, and I'm also going to add in some information towards the end of the video about some questions that are straight out for your final from the exponentials, logs, and statistics unit. Alright, so for this problem right here, solving a rational expression or an equation, what you should be able to do is try to get rid of any factor that's on the bottom of your rationals. Okay, so that would consist of x plus 2, you should notice it's on all of them, and the x plus 1 that's here and here. So what you're going to do is you're going to multiply by x plus 2 and x plus 1 on all three fractions. That's going to cancel these out, and if you would put an x plus 2 and x plus 1 up here, you would notice that the x plus 2's would cancel out, but that x plus 1 would still be up there. Okay, so basically all you're going to have to do is add these things together on the left side, alright, and then on the right hand side you're going to have to multiply that 2 times the x plus 1. So I'm going to do that real quick. Alright, so in red I wrote out, what I just said, 3x minus 1 plus 4x minus 5 equals 2x plus 2. I multiplied the x plus 1 times the 2. In the orange I went ahead and added like terms that were on the left hand side. And now what I'm going to do is I'm going to go ahead and finish up solving. So I would subtract 2x from both sides of the equation. Okay, what that would give me is 5x over here. And I'm going to go ahead and I'm going to move this minus 6 by adding 6 to that 2. Okay, that would give me 8. And now if I divide both sides by 5, that's going to give me 1.6. Okay, so there's my answer. I could check it, I can graph it, and look at where they cross. Any of those things would work. Alright, on here, I'm just going to make this real quick. I would check it with the graphing calculator to be sure, but the only thing that I can see right off the bat is that that constant, negative 24, should be my y-intercept. That's always the case. So that's why C is the correct answer. Okay, that y-intercept should be at negative 24. Alright, here on 19, you're going to need to factor. I'm going to do that real quick. Alright, so I paused it and did that. You might want to look over how I got this, but this is how that factors. And now all I'm going to do is cancel out anything that should divide out to equal 1. So that's it, y minus 1 over y minus 4. Alright, if you're trying to find the domain of a function, I would always suggest graphing it, looking at the table. Looking for errors is what you're trying to do. If you did that, you would see that there's an error at negative 2. You should also notice that that's what's going to make the denominator equal to 0. Okay, so that's why that's an error. So what this means is your x values, your domain, can be any number that you like except for negative 2. And that's because it's going to create an error. Alright, here you're going to need to factor again. So I'm going to pause this video, factor, and then you should be able to figure it out. Alright, so right here, that's all I did was factor. Okay, with one extra step. If you have division, you should remember that you have to flip the entire fraction that comes after the division sign. So that's why my factors are actually upside down. I did flip it. So now I'm going to cancel anything that cancels. I have these two factors on top and bottom. I have an a plus 1 on top and bottom. And I have an a plus 2 that's on top and bottom. And that's why my answer is a minus 2 over a plus 6. Okay, I really did mess up with the 8s. I don't know how they got there. Alright, here we're going to add fractions basically that have the same denominator already. Okay, that's easy enough. You just add the tops. So if I do this, I'll notice that I have the like terms of 3x and 2x, and that's why this is my answer here. The bottom should stay the same. Alright, this is a little bit small, but which graph represents the function? Okay, so many different ways to do this. You can factor it, use that to figure out where your intercepts are at, or just graph it. Okay, so I know that the answer is B. Alright, and really you can just use a graphing calculator. Alright, what are the roots shown here? Well, roots just means x-intercepts, so that's negative 4, 2, and 7. B. Alright, describe the end behavior of that graph. Well, that graph looked like this, with the left arm going down, the right arm going up. Okay, so that means, okay, can't be this one, and it can't be this one, because one of them says they're both up, one of them says they're both down. So we just have to figure out between these two answers which one means the right-hand side is up. And that means that the positive side of the graph, the x is positive on the right, is going up. So that's why this is B. Alright, we just answered a question like this. What's the domain of the function? Again, you can check the table, you can check the graph, or you can understand the concept that here you cannot divide by a 0, and that would be if x were 10. Alright, here on this problem, you would need to factor every single part of it. Alright, you may want to pause it to look at my factoring just in case you need some reminders on how to do that. Okay, but again, you're going to cancel out factors that are on top and bottom because they should cancel. And this on top kind of does look like a 9, but that is a 4. X plus 4 over x plus 9. So again, here we go. There's your right answer. Alright, this one's extremely easy. Because of that division sign, you need to flip this fraction. Okay, so you'd still have x plus 2 over x plus 4. It's just the second fraction is now x minus 3 on top, and the x plus 2 goes to the bottom. And then they would cross out. So that's why B is your answer. Alright, we just did a problem like this where you're adding with the same denominator. You just add the tops. Bottom should stay the same. And that's why 3x and 1x is 4x. And 5 and 8 makes 13. Here, you do not have the same denominator. So you don't just say 3 plus 2x. Okay. What you do have to do is make them have the same. So you'll notice they both have that x plus 3. What this one doesn't have is the x plus 4. And I'm struggling to get that written. Alright, so what you need is that x plus 4 on top as well. And I'm really trying here. Alright, so if you do 3 times x, you get 3x. 3 times 4 is 12. So that becomes 3x plus 12. The other fractions stay the same with a 2x up there. And that's really hard to tell, but that's 3x plus 2x, which is 5x plus 12. Alright, and the last question here is, what is the asymptote of this function? Clearly, if you do not have a clue, or even if you do, you may want, especially since this is a final exam, to use your technology. Graph this thing. Okay? Graph it. You will see where it's at. Now, you might not really be able to tell between -3 and -4, but it may bring back enough to your memory that it is at -3. Okay? For a logarithm, it's always here in parentheses. Alright, so I'm going to make a third video for y'all for the other information that's on this paper. So hopefully this helped. Go back and check the first problems if you need them. But study, study, study. Your final exam is Thursday or Friday, depending on when you have me.